A parallel circuits generally have two or more different paths for the electrons to travel through the resistors and devices. While both FM and AM radio signals experience frequent changes in amplitude, they are far less noticeable on FM. In low-power transmitters, where only a few watts of transmitting power are required, low-level modulation is used. Transmitters that transmit AM signals are known as AM transmitters. These transmitters are used in medium-wave, MW, and short-wave, SW, frequency bands for AM broadcast. Functions of each subsystem. An amplifier is used in order to increase the power of a signal. Amplifiers have some kind of gain that relates the magnitude of the output signal to the input signal. They can also be used in order to improve the video quality of screens installed in vehicles and smartphones. In addition, video amplifiers are used in video switchers and routers, and as a pulse amplifier in communications. Modulator. A demodulator is a circuit that is used in amplitude modulation and frequency modulation receivers in order to separate the information that was modulated onto the carrier from the carrier itself. A demodulator is the analog part of the modulator. A modulator puts the information onto a carrier wave at the transmitter end, and then a demodulator pulls it so it can be processed and used on the receiver end. Types of modulation. Amplitude modulation, AM, is the process in which the amplitude of the carrier signal is varied in accordance with the audio or modulating signal. Phase modulation, PM, is a digital form of modulation where it switches between different phases, 0, 1 binary. Is used for radio communications, mobile communications, and even maritime radio communications, Wi-Fi, satellite, etc. Frequency modulation, FM, is the encoding of audio signal on a carrier wave by varying the instantaneous frequency of that carrier wave. Applications for modulators. Amplitude modulation, AM, and frequency modulation, FM, are used to carry information on a carrier. FM offers greater clarity for audio and a wider bandwidth. One application where FM and digital are not suitable is aviation communications, which still uses AM. The reason is because weaker signals can be heard over stronger, closer ones with amplitude modulation, allowing for emergency transmissions to have a better chance of being heard over other traffic. AM uses a narrower bandwidth than FM. This is important for lower radio frequencies, where space is costly. An oscillator circuit to generate the radio frequency signal. This usually generates a sine wave of constant amplitude called the carrier wave, because it serves to carry the information through space. The signal generated by the oscillator is usually of constant amplitude. The wave shape and amplitude are determined by the design of the oscillator circuit and choice of component values. The frequency of the output wave may be fixed or variable, depending on the oscillator design. At radio frequencies and higher, whenever a fixed frequency with very high degree of frequency stability is needed, the component that determines the frequency of oscillation is usually a quartz crystal, which when subjected to an alternating voltage, vibrates at a very precise frequency. Radio frequency filter. A radio frequency filter is a device that is utilized to allow or stop selected signals or frequency, or used to eliminate, filter out any unwanted signals. Or it is designed to allow for the attenuation or transmission of a range of frequencies that would be applied. Frequency mixers can also be used in order to modulate a carrier frequency in radio transmitters. One of the main reasons for frequency conversion is to allow amplification of the received signal at a frequency other than the radio frequency or audio frequency. Operations of a transmitter. The radio transmitter consists of several elements that work together to generate radio waves that contain useful information such as audio, video, or digital data. Audio, video, or digital data. Operations of a transmitter. Slide 26. Oscillator provides a current at the frequency on which the transmitter will transmit. The oscillator usually generates a sine wave, which is referred to as a carrier wave. The modulator adds useful information to the carrier wave. There are two main ways to add this information. The first, called amplitude modulation, or AM, makes slight increases or decreases to the intensity of the carrier wave. The second, called frequency modulation, or FM, makes slight increases or decreases the frequency of the carrier wave. The amplifier amplifies the modulated carrier wave to increase its power. The more